Just set this week's timetable. Today is 13. Monday, 14th, Tuesday, 15th, Wednesday, 16th, Thursday, 17th, Friday, 18th, Saturday, 19th, Sunday. First practice, whatever taught in class. Then MCQ, we have done till 75. 76 to 80, only 5 MCQs I'm doing. Today evening extra you can attend?
So
No,
after
sir.
9.
After 9 only. After 9. 10 to 11. Can
Yes,
you attend
sir.
today?
Yes.
Earlier the better. So if you are having time, we'll do today 10 to 11. I want to take many lecture extra and complete your portion as per the given schedule. Tuesday, 81. Only 20 I am giving because some are slightly tricky. If you don't understand, you will find it difficult. 100 from that sheet, huh? From sheet given. Total, how many sums are there in that? 200. Just check it. Aman, check how many we have questions total. How many questions are there?
So 190, I guess.
Total 190 is there?
Yes, sir.
Okay. So test will be test on light from sheet.
No, sir, 200. 200.
Total 200 are there till 150 because more it I don't want to cut unnecessary put headache. Do something, but in such a way that you get full mark. Wednesday, whatever taught in class. Practice minimum 2 times you have to practice, otherwise you will not remember the concepts. And only 5 sums, 100 to 105. Then here 106 to 125. Then 125 to 130. Here 131 to 150, only 20 again. So test on light from light sheet 1 to 150. Friday, whatever taught in class, practice 2 times. Here we'll generally start with chapter called Kinetic Theory of Gas. Tuesday, any extra lecture possible to you all?
10 to 11.
Again, possible 10 to 11. So can I fix this week full 10 to 11? Daily 10 to 11?
So Wednesday not possible.
Except Wednesday, all other day possible?
Sir, tomorrow
Yes.
also it won't be possible.
10 to 11, 10 to 11.
Yes, sir.
10 to 11 also you are not free?
Sir, no. Sir, actually that Visarjan is there, no, 5th day.
So because of that, okay. ठीक है. Wednesday नहीं चलेगा?
Sir, Wednesday चलेगा.
कोई तो
So
बोला
for
था.
me it won't be possible.
So can you see the video lecture on that day?
Yes, sir, no problem.
तो खाली एक दिन देख लो. बाकी दिन चलेगा सबको ना?
Yes.
ये थोड़ा अपना पोर्शन
Yes.
थोड़ा एक 4 दिन पीछे that I can compensate. Because KTG I want to complete in this week. Please write down.
So,
Yes.
so on Friday also it will be 10 to 11, right?
All time same I have given, na?
Okay.
So that there is no confusion regarding time, when 8, when 9.
Yes, okay.
And please attend. Now, all the lectures are very important. As I said,
Yes.
physics will be the only deciding factor whether it is medical or engineering. Engineering वाले को थोड़ा maths strong थे. So shall I clear it now?
Yes.
I'm clearing it. चलो. Last we did in theory. In theory we did fringe width, correct? Fringe width we did, na?
Angular fringe width.
That is after fringe width. Note we did angular fringe width. Next one, Fresnel's biprism experiment to determine Fresnel's biprism experiment to determine wavelength of monochromatic light. Wavelength of monochromatic light. Aditya Pillai. Hello, Aditya.
Yes, sir.
You might have missed few lectures,
Yes, sir. A little bit.
but that all you have seen in the recorded lecture.
Sir, I have watched one video. Remaining two videos are there.
But that is there with you, or you want me to send?
Sir, you can send me.
No, in that group it is not there. On the group.
I'll check and see, sir.
Last week lecture you have missed, no?
Yes,
Or
sir. Last week lecture.
Only last week or many more?
No, only last week, sir.
Okay, just check. If it is not there, give me a message. I will send. If it is there, then go through it. Okay.
Okay, sir. Thank you, sir.
Yes. Hello. Fresnel's biprism experiment to determine wavelength of monochromatic light. Wavelength of monochromatic light. What is fringe width formula? Is it lambda d by d?
Yes, sir.
So if I want fringe width, wavelength, I should find capital X, capital D, small d. Barabar?
Yeah.
Okay. So let me heading written. So I can draw diagram.
Yes.
Diagram for Fresnel's biprism experiment. It consists of horizontal metallic bar fitted with meter scale. Horizontal metallic bar, usually 2 meter long, fitted with meter scale. Fitted with meter scale. It carries 4 stands. It carries 4 stands. This I am drawing for having uniform thickness throughout. It consists of horizontal metallic bar, usually 2 meter long, fitted with meter scale. It carries 4 stands, R1, R2, R3, R4. R4 is kept bit away, which can slide on horizontal metallic bar. It can be slided. Stand R1 carries slit, through which monochromatic light can be incident. So this is source S. Stand R2 carries biprism, which helps to split the light into two. This becomes two coherent sources by this biprism. R3 carries convex lens of short focal length, dotted, because इसका काम हमेशा नहीं है, it can be turned, इससे dotted दिखाया. It is only used to find distance between these two coherent virtual sources, which you can call S1, S2. इसका बीच का distance is found by that convex lens. It is not used during interference, therefore we have done dotted. Then micrometer eyepiece. Micrometer eyepiece. Micrometer eyepiece. It consists of two cross wire mounted on eyepiece so that it can be moved transversely. Light when comes here, it will give interference on the screen fitted on eyepiece. So from here we are observing this. Entire arrangement is called as optical bench. Diagram clear? Yes, diagram is
Yes, sir.
clear. Okay, please copy diagram part.
Done, sir.
Okay. I'm just clearing. Can I clear it off? If convex needs to be deployed. Shall I clear it? Yes, can I clear it?
Yes, sir.
Okay. So first paragraph I'm explaining about diagram. Then second paragraph onwards, calculations. We have to find lambda. That means capital X, capital D, small d. It consists of horizontal metallic bar, usually 2 meter long. Usually 2 meter long, fitted on fitted with meter scale. It carries 4 stands: R1, R2, R3, R4, which can slide over metallic bar. Stand R1 carries slit. R2 carries biprism. R3 carries convex lens. R4 carries micrometer eyepiece. 2 cross wires are mounted on screen in eyepiece, which can be moved transversely. Yes, done.
Done.
Okay. एक लाइन और लिख लो. The entire arrangement is called as optical bench. The entire arrangement is called as optical. Now I'm clear, huh? Adjustments. First, we have to do some adjustments. The slits and biprism are aligned in one direction and slit biprism eyepiece are aligned in one direction and distance between slit and biprism is kept at nearly 10 to 15 centimeter. The distance between slit and eyepiece is kept at nearly 1 meter. Now, slits are illuminated by monochromatic light. Slits are illuminated by monochromatic light and interference pattern is observed on the screen in eyepiece. Write down.
Done, sir.
Okay. Done, no? Okay. So we did adjustment. Now we have to do calculation. This is that optical bench. Here it is R1 on which we have slit, R4 where we have eyepiece. This will coincide with some marking of the scale. Suppose this is 10, this is 111. So difference will give me the distance. Hello?
Yes.
So can I find this directly just by noting this markings? Correct, na?
Yes.
So will it be easier to calculate capital D directly from the marks? Correct or not?
Yes, sir.
So first I will
Yes.
find distance D. The distance capital D between slit and eyepiece, that is source and screen, can be found directly with the help of scale fitted on optical bench. First part write down. So capital D we calculated directly, which is distance between slit eyepiece, that is source and screen.
Done, sir.
Okay. Then we can find X, that is fringe width. These are cross wires on the screen. On the screen, we get bright, dark, bright, dark, bright, dark, so many fringes. So first we make it to coincide with any one of the bright band. Any one. and we note that distance as x naught. Suppose it is 2 millimeter. Then these cross wires are moved up and made to coincide with nth band. That means after transversing few bands, not directly consecutive because they are very close and that difference may not be notable. So it is made to coincide with some nth band, maybe fourth, fifth, sixth, so on. And that distance is suppose 10 millimeter. So if x1 is 4 millimeter, then x1 minus x0 divided by 1 will give me fringe width. If I go to x2 6 millimeter, then x2 minus x0 divided by 2 will give me fringe width. Follow this meaning? If I go to third, then I will divide by 3 na, to get one fringe width. Yes or no?
Yes, sir.
So if I go to nth, then xn minus x0 divided by n will give me fringe width. So fringe to determine fringe width cross wires are made to coincide with any one of the bright band and distance x0 is noted. Then cross wire is made to coincide with nth band and distance xn is noted. Therefore, fringe width, comma capital X is xn minus x0 upon n. Copy.
Answer.
Okay. Now, third, to determine distance between d between coherent virtual sources. So to determine this distance, virtual means it is not seen on the screen. So we have to find it by image method. So to determine distance d between two coherent virtual sources, a convex lens of very short focal length is introduced between source and screen, that is slit and eyepiece. It is adjusted in two conjugate positions, L1, L2. Conjugate position means you will become we will become you in two position. Like if object is at 60, image is at 40. Next में object 40, image 60. It's called the conjugate position, L1, L2. And images are obtained as shown. So write this, then I'm drawing the diagram to show the images. Write this much, then we'll see the diagram.
That's it.
Okay. Just see the ray diagram now. This is for source. I've drawn one line, one position, screen. The source and screen का बीच में keep distance around 2 centimeter from here 2 centimeter draw line. Then this is symmetrical line on S1 S2. Take very close. Your book is ruled line. These are ruled line. So this is that symmetrical. Here S1, here S2 you take. This is our convex lens we have placed. Then ray diagram. We have to draw two rays. One passing through optical center remains undeviated. Passing through optical center undeviated. एक diagram हो गया है. Second ray parallel to principal axis. Join this with the lower wala. This you have to join. Join. Distance D. Position L1. S1 dash. S2 double dash. D1. This object distance is U1. Image distance is B1. Draw this diagram. Height of the image we have got D1 in first case.
Done, sir.
Okay. Again from S1 start, one ray. Pass through this optical center. With scale, you will get diminished image. Diminished, you will get like this. Diminished means smaller than the object size. S1 double dash, S2 double dash, this is V2, and object is U2, which is same as V1, image is V2, which is U1. Ray diagram, many times they ask in the exam. Draw ray diagram to determine distance between coherent virtual source. Only diagram for 2 marks they ask many of the time.
So,
Yes.
that U2 is equals to V1 from S1 to L2, right?
S1 to L2, yes, from this. This is object distance. The object from the lens is U2, but we have interchange in such a way that its value is V1. Then again, lens to the screen V2.
Done, sir.
Everybody is done?
Yes, sir.
At conjugate position L1, convex lens is close to the source S1 comma S2 and magnified image S1 dash comma S2 dash of height D1 is obtained. Let U1 comma V1 be the distances of object and image respectively. Now, since linear magnification comma m equals to height of image upon height of object, this is equals to distance of image upon distance of object. Therefore, height of image we got D1, object D is V1 upon U1, equation 1. Please copy first paragraph again. Done with the diagram?
Yes, sir.
Done, sir.
Okay. Everybody has done? At conjugate position L2, convex lens is placed close to the screen. And magnified image S1 double dash, S2 double dash of height D2 is obtained. Let U2, comma V2 be the distances of object and image respectively. Therefore,
Diminished image, right?
pardon?
Diminished image, right? Right.
Yes, yes, correct, correct. Thank you. And diminished image. S1 dash, S2 double dash of height D2 is obtained. U2, V2 be the distance of object and image respectively. Then linear magnification formula U2 upon V2. Copy this, then we'll write what happens at conjugate.
Done, sir.
Okay. At conjugate position L2, U2 is V1 and V2 is U1. Therefore, d2 upon d is u1 upon v1 equation 2. Multiplying 1 and 2, we get d1 upon d into d2 upon d is v1 upon u1 into u1 upon v1. Therefore, d1 d2 upon d square is 1. So d square is d1 d2. Therefore, d is root of d1 d2. Using above formula, distance d can be determined. Copy.
Answer.
Okay. So we have calculated capital D, capital X, small d. Correct? Yeah. मैडम कौन से स्कूल में है? हाँ, हेलो, हाँ वो, हाँ, मैं मैडम एक 10 मिनट में आपको कॉल करूँ ये नंबर पे? 10 मिनट में करता हूँ। थैंक यू। Yes. Fourth calculation. Since capital X is lambda d by d, therefore lambda is capital X small d upon capital D. So using above formula, wavelength can be determined. Using above formula, wavelength can be determined. Right.
Answer.
Diffraction. Next part, diffraction. This is separate part, diffraction. One is interference we completed. This is diffraction. See, if this is one obstacle, here is a screen, this is source. So light will come in all direction. Because of this, it will get obstructed. तो इधर आपको shadow दिखाई देगा ना?
Yes.
Correct? If there is small opening and this is the light, so upper part will be shadow, no?
Correct.
Shadow. से मैं घर पूरा अपना काला कलर से पेंट कर देता हूं, ब्लैक कर्टन लगा देता हूं और हेलोजन लाइट चालू करता हूं घर में. बाहर वाले को समझ में आएगा लाइट है क्या? आएगा क्या समझ में? वो अगर दरवाजे का ऐसा एंड पे देखेगा ना, थोड़ा थोड़ा लाइट दिखेगा उसको इधर ना. मतलब सब डार्क भी करके वो लाइट थोड़ा इधर से बेंड होके चला गया ना नीचे. बट सपोज इफ इट इज साउंड, एक ऑडिटोरियम है, ऑल कर्टन्स आर एब्सॉर्बिंग द साउंड, ऐसा टाइप का कर्टन लगाया, दे आर कॉल्ड एकॉस्टिक्स. और अंदर डॉल्बी सिस्टम चालू कर दिया. बाहर वाले को फिर भी थोड़ा तो आवाज आएगा ना. इफ सपोज यू आर स्टैंडिंग आउटसाइड द ऑडिटोरियम, थोड़ा सा कान लगाएंगे तो आवाज आता है ना हम लोग को.
Yes.
अंदर का
Yes.
तो बोलते हैं ना, दीवार को भी कान होता है. मतलब आवाज थोड़ा सा किधर ना किधर से बेंड होके बाहर आ जाए. दैट बेंडिंग इज कॉल्ड एक्चुअली डायफ्रैक्शन. साउंड वाला ज्यादा बेंड होता है, बट वी डोंट हैव दिस साउंड डायफ्रैक्शन इन सिलेबस, वी हैव ओनली लाइट. सो फिनोमिनन ऑफ bending of rays at the edges of obstacle or slits which can illuminate geometrical shadow is called diffraction. समझा क्या है diffraction?
Yes, sir.
shadow को illuminate कर दिया, उसको बोलते हैं diffraction. वो कभी होएगा when wavelength is greater than equal to डिस्टेंस ऑफ ऑब्स्टेकल और स्लिट. ऐसा अगर है वेवलेंथ ऑब्स्टेकल से ज्यादा वाला, तो ये ज्योमेट्रिकल शैडो को इल्यूमिनेट करता है. ये प्रॉपर्टी को डायफ्रैक्शन बोलते हैं. व्हाट इज डायफ्रैक्शन? क्लियर? इल्यूमिनेशन ऑफ ज्योमेट्रिकल शैडो. मतलब ये शैडो इधर तक था, तो ये थोड़ा बेंड हो गया, तो इधर हमको लाइट दिखेगा ना थोड़ा कॉर्नर्स में, इधर लाइट दिखेगा ना कॉर्नर पे, उसको ही क्या बोलते हैं? डायफ्रैक्शन. क्लियर? हेलो?
Yes.
द लास्ट पार्ट है आज के लिए. द फिनोमिनन ऑफ बेंडिंग ऑफ रेज at the edges of obstacle or slits which illuminates geometrical shadow is called as diffraction. Note: for diffraction, lambda should be greater than equal to d. D equal to size of obstacle or aperture. Write this much. I hope done.
Done.
Okay. So please revise this much. Stick to the planner. so that you are getting good marks that will be extended further till your final exams.